In the fourth session, we'll discuss about the Daniell cell, its working principle, salt bridge and its function, cell representation, electrode potential, factors affecting electrode potential, difference between electrode potential and standard electrode potential. Okay. Well, what is an electrochemical cell? Electrochemical cell is a device which converts the chemical energy into electrical energy via indirect redox reaction. The decrease in the free energy during this reaction appears as electrical energy. The most simplest form of electrochemical cell is Daniell cell. It is also known as galvanic cell. The anode consists of zinc rod dipped in zinc sulfate solution, and the cathode consists of copper rod dipped in copper sulfate solution. Both these rods are connected by the voltmeter. Anode is drawn in the left hand side, cathode in the right hand side, and the two solutions are connected using the salt bridge. In the next slide, I will show you the picture of this. You can see the electrochemical cell. Anode is in the left hand side, cathode is in the right hand side. Zinc rod is dipped in zinc sulfate solution, copper rod is dipped in copper sulfate solution. These two rods are connected by a voltmeter, and the two solution is connected using a salt bridge. Anodic reaction is basically an oxidation reaction. The zinc is converted to Zn2+, that is, the oxidation state increases or it loses an electron. The cathode, Cu2+, becomes Cu, that is, oxidation state is decreased, which means the reduction takes place, or the reduction can also be said as acceptance of electron. The overall reaction, it's quite simple. The reaction can be shown. Just look into this. This is the overall reaction. You can see that the two solution was connected by salt bridge. So it is one of the most important part of the electrochemical cell. Salt bridge is a U-shaped tube made of glass filled with semi-solid paste of potassium chloride, ammonium chloride, potassium nitrate, sodium chloride in a agar-agar gel or gelatin, so that it forms a semi-solid paste. The electrolytes used in this are inert, means they do not interfere with the electrochemical reactions taking place in the electrochemical cell. What are the main function of the salt bridge? The main function of the salt bridge is to complete the circuit and to maintain the electrical neutrality without mixing of the solution. Now you should know how to represent an electrochemical cell. In the representation, the anode is written on the left hand side, while the cathode is written on the right hand side. Anode represents the oxidation half cell, whereas the cathode represents the reduction half cell. The salt bridge is indicated by placing double vertical lines between the anode and cathode. Now let us write the expression for the Daniell cell. Zn solid. There is a single line which separates Zn solid and Zn2 plus. That is because zinc is in the solid state, whereas Zn2 plus in the aqueous state. So this change in the phase is represented by a single slash, whereas the salt bridge is represented by a double slash. Again, you can see a single slash between Cu2 plus and Cu that shows the phase change. Now if you look into the left hand side, which I have already stated is the anodic oxidation half cell. Why we call it oxidation? Because Zn becomes Zn2 plus, that is oxidation takes place. And in the cathode, Cu2 plus becomes Cu, that is reduction takes place. Now let us write another example of this representation. Cu solid, a single slash CuSO4. It is dissolved in water, therefore AQ, a double slash. Silver nitrate again is a solution in water, and you got solid silver. So this is the copper silver electrochemical cell. This is how we write or represent the electrochemical cell. As a result of electrochemical reaction, zinc dissolves into anode solution, while Cu2 plus are discharged at the cathode. Discharged at the cathode means they are deposited at the cathode. Since the electrons are released at the anode is negatively charged and the cathode is positively charged. Whereas this is opposite in the case of electrolytic cell. Now let us understand the concepts of electrode potential. What is electrode potential? When an element is placed in its own solution, it has a tendency either to gain or lose electron. This tendency is known as electrode potential. You can see in this picture, I have shown the copper rod dipped in copper sulfate solution. This is an example of element placed in its own solution, copper rod in copper sulfate solution. You can also take zinc rod in zinc sulfate solution. This copper will have a tendency to go into the solution. Similarly, the Cu2 plus will also have a tendency to become copper. The tendency of Cu to become Cu2 plus is known as oxidation potential, whereas tendency of Cu2 plus to become Cu is known as reduction potential. Okay. We can write this oxidation and reduction potential as shown in this equation. Depending upon whether it is a tendency to gain electron or to lose electron, the electrode potential can be called as reduction electrode potential or oxidation electrode potential. Remember, tendency to gain electron is reduction electrode potential and the tendency to lose electron is known as oxidation electrode potential. Oxidation potential is actually the reverse of reduction potential. And if you place a metal or an element in its own solution, you cannot determine the electrode potential just by simply having this arrangement. That is the reason we say that electrode potential cannot be determined in isolation. Now you know that what is electrode potential? It is a tendency to either gain or lose electron. Therefore, there are two types of electrode potential. One is oxidation electrode potential and reduction electrode potential. As per convention, we'll only discuss about reduction electrode potential because that is what is used as per IUPAC. So how to represent the reduction electrode potential? The reduction electrode potential is represented like this. Now take a specific example. Say for example Cu. It is written as electrode potential of Cu2 plus bar Cu. Cu2 plus bar Cu means Cu2 plus is becoming Cu, that is reduction electrode potential. Now if it is the case of zinc, then we will write it like this. So remember the oxidized state followed by the reduced state. That is only the way you have to write the reduction electrode potential. Now let us look into the factors affecting the electrode potential. It depends upon three factors. It's very important. What are those factors? One is nature of electrode. So it will change depending upon the nature of electrode. The electrode potential of copper and the electrode potential of zinc will be different because they are different electrodes. Second, it will also depend upon the concentration of the solution. And the third factor, it will depend upon the temperature. Now, there are three factors on which the electrode potential depend. Now, if you want to compare the electrode potentials of different metal, so to get the correct comparison, we'll make any of these two factors a constant. Say for example, if we make the concentration of the solution fixed and if we fix the temperature, then there are only one factor will affect the electrode potential. Now how that is done, let us look into it. If the concentration and the temperature is specified, That is, if the concentration is 1 molar and the temperature is 298 Kelvin, then the electrode potential is known as standard electrode potential, and it is denoted as E0. Now what is the difference between E and E0? E is a reduction electrode potential. We call it just electrode potential by convention. It is always the reduction electrode potential, whereas E0 is standard electrode potential. That means standard electrode potential will be a constant because the concentration and the temperature is specified. The concentration is 1 molar and the temperature is 298 Kelvin, that is 25 degree Celsius. So you should clearly understand the difference between an electrode potential and standard electrode potential.